Hello, my name is Lewis Mota, and for this data science in context presentation, I am going to talk about geographical information systems that are also known as a GSI. Since this is a short presentation, I'm just going to give a high-level overview about what is a geographical information systems, what are the type of data models that it uses in order to represent real-world objects, what are its applications, and what are the advantages and disadvantages of this kind of systems. So let's get started. What is a geographical information system? A GSI is an organized collection of computer hardware, software, and geographical data that is managed by people in order to model real-world objects. So this basically means that people capture the data about any specific geographical location, and we model that information into a database in order to perform analysis in the same way that we can do with any other kinds of data in a data science context, and then get insights about a specific population or a specific phenomena that is happening in the world. For that matter, it is composed of many components such as hardware that are used in order to get the data from the real world, the software that is used to model the data, and the analysis that is basically, as I mentioned, analyzing the information in order to get insights. As you can see, I mentioned that we can perform analysis and we can model objects, but how does a geographical information system do that? In order to do that, a geographical information system uses layers that are basically divisions that represent the same location but in a different level in order to create architectures that allows to separate the information in different components, so we can perform an easy analysis when we are trying to get any insights about the data. As you can see in this graph, we can, for instance, have the street data that could be a database that only represents the streets in a specific city. Then we can have another database that is the buildings data that, as it suggests, it has the data for buildings, the vegetation's data that also models the type of information that it suggests. And finally, all the databases together combined form an integrated database that is linked by index IDs that can be used in order to relate the different databases. And an analyst can perform analysis in any single layers that he wants in order to get insights about data. As I mentioned, the data is stored in layers. However, that's not the only feature that a GSI model have. In order to model the real-world objects, it uses spatial data that describe the absolute and relative location of a geographic feature, and also the attribute data that describe the characteristic of that feature. And those characteristics can be quantitative or qualitative. For instance, that could be how long a building is, how long a street is, or how tall a tree is. As I was explaining, there are two different type of data that a geographical information system uses in order to model real-world objects, and those are the vector mode or coordinate-based type of data structure that uses a vector that stores points, lines, and polygons that are called features. In this case, those objects are used in order to delimitate the geographical information that we can observe in the real world, and that information is stored in a database that stores that same information using x and y axis. And also the objects that are related to that same no, that same feature can be also modeled as points and lines. So basically a point could be, for instance, a building that is located in this part of the in that part of that geographical area, and the polygons could be the delimitations of that area, and the lines could represent the street, and all those objects are represented in a database, as you can see in this example. That example is not complete because it doesn't have the x and y coordinates, but that's just to give you an idea of how it stores the information. In that case, each object is linked by ID and is also by IDs and are also represented with a unique ID. And in that way, they create the relationship between objects. A second type of data that is used to model the information is the raster mode or grid cell, that is similar to the polygon mode, but the only difference is that it doesn't have the same level of detail with we speak about the shapes, because the information are represented as cells that you can see them as pixels, and in that kind of data structure, each cell has their own values. It offers an advantage compared to the vector mode, because we can like give different level of granularity to the information. And this is a comparison of how each model represents the data. As you can see, as I mentioned before, the vector represents the data in a more detailed way, because we can create polygons that can adapt to the shape of that geographical feature, and it could also provide a best level of detail. However, the raster representation, even though it's not as accurate as the vector representation, allows to store more information about the object that you are modeling, and it allows you to represent each single unit of measure of that object with a different level of detail, which means that you can store information for that same polygon that you can see there and there with different level of information. And what are the applications of a GISI? For instance, the GSI can be used in retail businesses. For instance, they can use that information in order to determine where to locate a new store, or simply the other kind of businesses such as restaurants can use it to decide where to perform marketing. For instance, also scientists uses GIS in order to compare population statistics to resources such as drinking water, or even also in order to determine what are the area where certain species live and what are their migration patterns. Also, the Syria states or the federal officials can use the GIS in order to plan their response when an events happen, which means that in the case of a natural disaster, they can in some way model and predict where would be the most secure locations where they could put the people. And also engineers have a use for the GIS, That is that they can use it in order to model, for instance, how they are going to install certain network connections, or how they are going to design a street in the case of a cyber engineer, or how to locate the infrastructure of internet connectivity. Finally, what are the advantages and disadvantages of a geographical information system? Basically, the advantages relies in that it can provide a solution for the problems that it can model and predict disaster precisely. And a second advantage is that it allows us to perform data analysis at different levels, so we can perform descriptive statistics and inferential statistics. So basically, the advantages rely in what it can do. What it can do. However, the disadvantages are that geographical information systems are a very expensive software, are and in the same way they are very difficult to populate with data. So basically, you will need a lot of resources in order to get the data. In addition, it has privacy violation, which means that since you have already the data that some people have put in there, if you for some reason decided to use that kind of system, you could also see the same type of information that many other people is using, and you can use that information according to your own interest. Another disadvantage, that is one of the main disadvantages, is that the information that you put in a geographical information system has to be accurate, because if the information is not accurate, basically you would be inputting information that is wrong. And the reason for that is that the model that it uses in layer is dependent of the other model most of the time. And when you put information in one model that is wrong, you are creating a reference to a model that is not correct. And that causes a chain effect in the model of the database. And finally, that the data fields and their accessibility are not very understood, and the data can become incomplete, obsolete, or erroneous. And that part has to do with the data types that can be confusing depending of the features of a specific real-world object. And with that, I conclude my presentation. Thank you for your attention. If you have any question, I will try to be available on chat so I can answer any inquiries that you have. Thank you.